Yay, we're at the last section of Chapter 1, Lesson 1.6, where we're actually solving absolute value inequalities. We're going to address the objectives. How can we use compound inequalities to solve absolute value inequalities? How do I translate absolute value inequalities using a less than and a less than equal to symbol? And how do I translate absolute value inequalities with a greater than and greater than or equal to symbol? So remember that when we were solving absolute value equations, we were looking for a range of values, and we needed to translate the single absolute value equation into two equations without absolute value. So consider, what concepts have we been discussing that also applies to a range of values? Well, those are the compound and the compound and the compound or. So how do you think we could use these compound inequalities to help us solve absolute value inequalities? Well, we're going to translate the absolute value into an appropriate compound inequality. We're going to translate the absolute value inequality into a compound inequality. All right, so absolute value that's combined with a less than, a less than, and a less than equal to. So let's figure out how to take that and translate it into a compound and, or why it translates into a compound and. So this expression here, absolute value x is less than 3, says that I'm looking for values that are 3 units or less away from 0. So if I mark 0 here, and I count 3 spaces to the right, okay, and I count 3 spaces to the left, I would be looking for all the values between these two numbers. What is that a graph of? Well, we learned yesterday that's the graph of a compound and. And how do you write that algebraically? Well, you're going to put your smallest value on the left. You're going to put your variable in the center, and you're going to put your largest value on the right, and then you're going to use less than symbols. Okay? And we're going to do this before we solve anything. Okay? So let's try that, and let's try and solve one. Here we go. So here's my original inequality. Absolute value, x plus 1, is less than or equal to 3. So I'm going to take this number, and I'm going to take the negative of it, put it on the left. Then I'm going to take this number as it is, and I'm going to put it on the right. And then I'm going to put my expression in the center. We just wrote a compound and. The opposite of the number goes on the left, the positive of the number goes on the right, and the expression goes in the middle without absolute value bars. Notice that the absolute value bars are gone. Now I'm going to isolate my variable. I do that by subtracting 1 from every section. So I get negative 4 is less than or equal to x is less than or equal to 3. There's my solution. Set notation is all x's such that negative 4 is less than or equal to x is less than or equal to 3. Oops, that should not be 3. Silly me. Hope you caught that. That should be 2. In interval notation, I'm going to have my smallest value is negative 4. I love it when my pen works well. -4. My largest value is 2. And then I have to decide whether I have parentheses or brackets. The 4 is associated with this inequality symbol, so that means it's a bracket. The 2 is associated with this inequality symbol, so that means that it is also a bracket. So if I have 0, 1 and 2, -1, -2, -3, -4. Oh, my 3 looks crummy. Okay. Then I'm going to do closed-in circle on -4, closed-in circle on -2, and it's an and, so everything has to go in between. Those are your solutions. Try one more, a little bit more complicated. All right, we're going to write a compound and. We're going to take the opposite, and we're going to go -17 is less than or equal to 5x plus 2. Notice I don't have any absolute value bars, and then I'm going to take the positive of this number. Okay, I have to get the x all alone, so I'm going to subtract 2 from every section. And then I'm going to divide by 5. That's the coefficient on x. And then I get -19 fifths is less than or equal to x is less than or equal to 3. And I'm going to go ahead and write it in set notation, add the pretty stuff. Interval notation, I need brackets on both ends because they're both, with absolute value, your ends, your brackets and braces are always going to be the same thing. Not true with a compound, but with an absolute value, yes. And then 3, scoot that in a little bit. And then I'm going to graph it. So here's 0. And then -1, -2, -3, -4. I'm not quite -4, so I'm going to call it here. That's -19 fifths, and it's going to be closed in. And 3, and it's closed in, and it's an and, so it has to go in between, just like that. Okay, now we're going to switch gears, and we're going to look at the or, and how we translate an absolute value with greater than. Highlight this. If you have a highlighter with you, highlight this, because this is greater than or equal to. That's going to translate into an or. Less than equal to went to an and. Greater than is going to go to an or. Okay, so we're looking for numbers that are more than 5 units away from 0. So if here's 0, and I'm going to go up by 2, and then down by 2. Okay, and here is -5, and I want more than 5 units away from -5. Okay, so that means I have to go off this direction, right? Because if I went to the right, it would be closer. And then if I go here at 5, then I have to go off to the right. So do you see how a greater than is going to produce a compound or? So before we attempt to solve any absolute value inequalities, if they have a greater than or greater than equal to symbol, we're going to write it as a compound or first. Okay? All right, So let's try this one. I have 2x minus 6 is greater than 12. So that means I have to have 2x minus 6 has to be to the left of negative 12, so less than negative 12, or 2x minus 6 is great. Oh, I can't read that. I gotta start over. Bummer. So I have 2x minus 6. Watch this. It's got to go off to the left, so it has to be less than negative 12, or 2x minus 6 has to be greater than, gosh, I'm just really having a hard time writing. Let's do it like this. 2x minus 6 is greater than 12. And we're going to solve both of those separately. Solve them separately. So I'm going to add 6, which says that 2x is greater than negative 6. X is greater than negative 3. Divided by 2, just in case you weren't sure. And then 2x is greater than 18. X is greater than 9. Notice that these are both going greater than, aren't they? Right here, okay? So I need to go from negative 3 to 9. So let me try this. If I do this, this is 0, negative 2, negative 4. I don't know what's going on with my pen. It's a mess. Here is negative 3. It's going to be open and going to the right. And then 2, 4, 6, 8, 10. Here's 9. It's going to be open and to the left. And when we had a compound or and they were both going in the same direction, remember what we did? We picked the longest line. So this is all x's, such that x is greater than negative 3. And in interval notation, it's going to be parenthesis, negative 3, comma, positive infinity, parenthesis. That's going to cover it all. All right. Now, the next thing that we're going to do is we're going to take a graph and we're going to learn how to write an absolute value inequality from it. 3 things you need to know. You need to know first, is it an and or an or? And you're going to be able to tell that by what? By what the graph looks like. If you have 2 endpoints and a line in between, you have to have an and. All right? Then what we're going to do is we're going to find the centering number. Okay? Basically, you're going to find the midpoint between those endpoints. So the midpoint, you're going to add them together, add your endpoints together, and divide by 2. You're going to find that average. So I get negative 1/2. That's my centering number. So here's my center, negative 1/2. Okay? Now you're going to determine the distance that the endpoint is from the center. Watch your scale, because in your book, your scale could be more than 1. In our case, it is 1. So it's 1, 2.5. Our distance is 2.5 units. Then all we do is we just create this expression. We have absolute value, x minus that centering number has to have some relationship, either greater than, less than, and that's going to depend on your graph. In our case, it's an and, so that means it has to be, our endpoints are included, so it has to be less than or equal to, and then our distance. And we're going to plug all that information in. We know it all. We know each one of those pieces. Okay? So we have absolute value x minus a negative 1/2 is less than or equal to, my distance is 2.5. This is D and this is C. Okay? So we would have absolute value x plus 1/2 is less than or equal to 2.5. All right, let's try one more. Determine if the graph is a compound and or a compound or. Well, look what's happening. Our graph is going off in different directions, right? So what does that have to be? It has to be a compound or. So we know that we're either going to be greater than or greater than equal to. What do you think it's going to be? It's going to be greater than and equal to. What's our centering number? Our centering number is going to be -1 plus 3 divided by 2. Add your endpoints together and divide by 2. Average them. And I get 1. Here's my center right here. What's the distance? 1, 2. The distance is equal to 2. This is C. And then we plug it in to the standard equation. Absolute value of x minus c. Well, what's c? Well, it's 1. So it's x minus 1. It's greater than or equal to because we can tell because the branches are going off in opposite directions, and it's greater than the distance 2. X minus 1 is greater than or equal to 2. All right, these are the problems we're going to work on tomorrow. So I'll see you then. Quizlet's due on Friday, and we got a test coming up soon. So let's get prepared. Thanks. Bye.